now we continue with ancient metallurgy with the lecture of Alessandra Giumlia Mair from Italy. It would be scientific methods applied to ancient metallurgy.
So, how does this work? Is it? I'll try.
Very easy.
Oh. Very happy to be here. I've learned quite a lot in these 2 days, and apologize because of I cannot speak Russian, not really. I can only follow a bit. The topic I'm discussing today is quite complex, actually. Why? Because in archaeology we are dealing with different metals, and all of them, as we have heard just now, with iron, for example, they have different behaviors, different characteristics, and they are also produced in different ways. We have around 10 metals which were used in a way or the other in antiquity, in archaeology. We also have a very wide choice of analytical methods which are not always used as they should be, because people tend to use what they have in their lab, and instead of looking for the best way to solve a problem. It is, of course, a problem sometimes with some papers which present results which are not, cannot be used. There is no method which is good for everything. This must be clear. So what I'm presenting today is a very general view on methods that can be applied in several cases, not only for one metal, not only in one occasion, whatever we can do. I'm not going to discuss iron because the case of iron is different. With iron you need a sample, you need to take a sample, and you need metallography to do a proper work. So I'm leaving this out. What do we do first when we have objects made of metal? The first thing to do is, of course, the autoptic examination with my eyes first, looking for details, looking for traces of working, traces of use, for example, and then we pass to better tools like lenses or microscopes in general. What about copper-based alloys? Why do we have to look at copper-based alloys? Because in an oxygenated environment, and I mean in the soil, of course, in the earth, the first kind of alteration which forms is cuprite, which is the, oops, sorry, I'm going to kill you with this. This is cuprite, the red one, which is an oxide. This cuprite reacts with the soil and forms carbonates, which is the common malachite, the green malachite you see here. In some special environment, and I'm talking about Sicily, for example, or Crete, where I've been working for many years now, you get azurite out of the earth because of the dry environment. All of these have been used as pigments as well. Optically, we cannot distinguish the metal which is patinated. The patina looks just the same on copper, on bronze, on brass, and even on silver. Several times it happened to me in a museum. I was given patinated green objects. They thought they were made of copper or bronze or something, but they were made of silver. So we have to be very careful. We need to analyze them. The first kind of analysis to be used is, of course, non-destructive. You use X-ray fluorescence, which is, however, a surface analysis. So there are dangers and problems with this as well. There are also different kinds of systems, equipments, the desktop equipment, the common one, portable ones, and we have problems with it, of course, because these kind of portable XRF have been produced for the industry. So we have no way of controlling the beam, the radius of the beam, if it hits the surface in the proper place. And also we cannot narrow down the beam as we need or enlarge it. Sometimes it is important to do it. So there are many problems with this. We have been using it both just now in Pompeii, in Naples, at the museum, and using them parallel, in a parallel way, and there were a lot of problems with the portable one. I am using normally this kind of equipment here, which consists of a transformer here, a stabilizer, a computer. They are on a table here, and this is the head of the system, which can be moved as it is necessary. In this case, I was analyzing this big statue in Umbria, in the region Umbria, which is higher than 2 meters, the statue, and it was also on this high basis, a pedestal here, higher than 1 meter, so I needed a high scaffolding, over 3 meters high. It works very well with this. What is important is that we have to choose very well the spots, the different spots we are analyzing. With this statue, it was easy because it was found broken, and there were many places, many spots where the patina was missing. So I could go down to the metal. There are important differences in the patina structure. It depends also on the different working techniques, of course. You can see these are spectacle fibulae from Germany, from Regensburg, Castra Regina. The fibulae are dated to Hallstatt C, so Iron Age. And you can see, I hope, the difference of the patina here. This is the noble patina, thin and very shiny and compact. Look at these rivets here, these here, these here, these here. The patina on them is very rough, very thick. So this kind of patina absorbs elements from the earth. So you suddenly have zinc, where there isn't any, you have iron, you have a lot of stuff which is not there really. And many elements are lost in the soil. This patina loses elements. You lose tin, you lose lead, of course, and so on. So it is very, very important to look exactly where you are doing these measurements, and you also need some experience. These are not only, of course, malachite and azurite and cuprite are not the only kind of patina. There are many other ones, and they should be avoided. So it's important to have experience with these things. So we need more precise results, of course. I normally use atomic absorption, spectroscopy, or ICP. Don't worry, I'm not going to explain how it works. There is no point. You can find it anywhere. What is important is that these kind of methods are very precise, and you get proper results also regarding trace elements, which are very important to reconstruct. First of all, the provenance, the technology, the production of the object. The problem with this kind of analysis is, of course, that you don't get the results immediately. Of course, with a portable one, a pistol, you get numbers immediately, but they are not reliable. With my transportable one, which is bigger, you need to elaborate the data. There is a program for that, so it takes longer. But with ICP and atomic absorption, you need the samples, which is destructive, and you need to prepare a solution. The solution can then be analyzed, so it takes longer simply, but it is very precise. Now, the destructive samples, don't think that I take a big chunk of metal out of the statue, for example. The samples are very small, 10 milligrams. I use a jeweler drill, a tiny one, with drill bits which only have 0.8 millimeters to 1 millimeter. So you get this kind of hole here, and this piece is this one. This volute belongs to a statue which came out of Pompeii, and I've been working on this in Naples a couple of months ago. The small hole is then closed with paraffin or graphite, whatever you prefer, so to avoid humidity, for example, or problems with that. But it's very small, and it is important to have this kind of analysis to get really precise results. In the past, I've also been using prompt gamma ray activation, and I was not happy about the results at all, because I had, of course, small items, because we put them in the chamber, and they were patinated. It was fibulae, small objects, and so on. And so the results I had were terrible. I was not happy about them at all. And also the pieces were radioactive afterwards, which is not something you like really. And the same problem was with neutron activation. So I tried to avoid that if I can, of course. Yes, I've been using tomography as well. Particularly in the case of the big bust of Septimius Severus from Avanches. It is gold, that big. It's a big chunk. So we used tomography for that as well. It is published, it is online on academia, so you can read it. For details, when we have spatial questions like how was the gilding done, which kind of gilding is this, there are several possibilities, of course, or we have small details like inlays, decorative parts and whatever. I use the scanning electron microscope, of course, which is very, very useful. For example, we also had the examination of the iron oxides, which are on these Iron Age knives from Austria. You can see, I hope, here on the knives, here, the imprints of textiles. So we wanted to know which kind of textiles these were. And this is the picture I got on the scanning electron microscope. You can see the structure of wool fibers. So we knew that the textile was made of wool. In this case here, this was an ornament on wood from Bologna. It is an Etruscan Villanovan piece. It was very interesting. And in this case, we found linen fibers preserved in the tin oxides. So it's quite interesting to use, of course. Sometimes we have decorative materials which we cannot identify precisely. For a long time, these inlays in these fibulae, leech-type fibulae from Slovenia, from Mostna Sochi, you can see the inlays, they are white, and the XRF said that it was calcium carbonate. Calcium carbonate can be everything, can be ivory of elephant, or boar tusks, coral, antler, bone, shells, so we had to look at them to find out what it was. Well, at the end, it wasn't any of that. It was not organic. It was stone, calcareous stone from Istria. But it is useful to know about the structure of elephant ivory, antler, and bone. This is quite an interesting piece here. It is a horse pit found in northern Italy, in the east, where I come from, Trieste, that area. It is dated to the Iron Age, early Iron Age, and I wanted to show it to you because it is found in Russia as well, and it is found in Moldavia, in Romania, in Hungary, and so on. And it is antler in this case. This is ivory or boar tusks, which is a material which has been used well, all over Europe at different times as well, but it is seldom recognized because nobody looks at it. People say, okay, it is ivory or bone or something, but it can be boar tusk. You have to be careful with it because you can see the different structures here and here. They are slightly different, so they can look like elephant ivory or shells, like these. These are shells from the sea, but they were also exported to other places, in places where there is no sea at all, and they were used as decorative materials. So it is quite important to know all these structures, and you can do it on the scanning electron microscope. I've been using the scanning electron microscope also to check the patina of a fake statuette. It was quite big. It was said to be an Etruscan statuette. It was not Etruscan at all. This is the fake patina we had inside the statuette. It was whole, and you can see it was produced with acids. It was a loose patina. It was not the real thing. And the outside patina was not bad. You can see it here. This is, of course, a picture taken at the normal optical microscope. It was made of ground copper-based alloy, real corrosion, ground to dust and mixed with glue. If you look at it here, maybe you can see the bubbles in the glue. So it was applied with a glue. When we have crystalline materials, we use X-ray diffraction, of course, to find out to identify the kind of patina, to identify pigments like cinnabar, malachite, azurite, calcite, and so on, and also for niello. I've been using it for niello as well. I'm very interested in niello, so I thought I would show you these as an example. This is a Rhyton which is in the Trieste Museum. It comes from Taranto. It was found on excavation in Taranto, in southern Italy, and it was sold to the Trieste Museum in the 19th century. At the time, Trieste was Austrian Empire, and they could buy and sell antiquities. So it is a Trieste, and there I could analyze it. This is for the moment the earliest example of niello ever identified. It is dated to around 510 BC, And it comes certainly from the Black Sea area, not only because of, well, you can see there are many parallels around the Black Sea, but also because of the legend, because of the myth which is represented here, which is the myth of Boreas, a god who was living on the Black Sea. You can see that this object is decorated with niello around the eyes, you can see it here, and the nose and the mouth. You can see that the niello is inserted in the lashes here. So this technique is already very, oh yes, this is important. Early Egyptian and Mycenaean black objects are not decorated with niello. This is an artificially black patinated alloy which contains low amounts of gold and silver, 1% of gold, 1% of silver, different amounts of course, and also sometimes some arsenic and iron, 0.3% or something. And this alloy is artificially patinated in a solution containing copper salts. I published this, I brought a copy of my paper, I have it there, so if somebody wants to look at it, I have it with me. So this is not niello, this is something completely different. I've been looking at many different some more examples from the Black Sea area. These are two writer from the Ortiz collection in Switzerland, and maybe you can see the niello around the eye here, and in the mouth here, and in the nose. And this piece here is in the Miho Museum in Japan. Also this one has the same kind of working technique. All of them are stolen, of course, and they are all dated to the 5th century BC, so they are slightly later than the Rhiton from Trieste. These are other ones. This one is also stolen. It is in the Metropolitan Museum. You can see here, maybe, I hope, some niello on the eye. You can see how it is worked. There was niello all over. Of course, it has been cleaned very thoroughly, very well cleaned, but it is still there. There is some here, and there is some in the nose as well. And these are the writer from Rosovec in Sofia, at the museum in Sofia. So this one, the Rosovec A, I call it, has a lot of problems of corrosion, so you can't see much now, but the way of working is the same. I'm sure there was niello here too. And you can see some niello here, I hope. Can you see it? Yes, okay. And you can see how it is worked here. There was some niello inside here in these grooves and on the lashes, just like on the Trieste example. So why am I showing you this? Because I'm interested in Russian niello, of course. As I said, all these pieces show a very developed technology. All these writer fantastic pieces. It is certainly not the first time that niello was used. So there must be some more objects, pieces, which are older and which are decorated with niello. I'd be very interested to hear about this in the future. Maybe some of you will be working on it. I hope somebody will accept this suggestion. And I thank you very much for your attention.
Alessandra, please questions. I had the question from the beginning.
Yeah.
So, how did laboratories, they are in the framework of the universities, they are in the museum. What is the strategy? Do you have several large laboratories, or it is all split into some smaller places?
Oh, well, normally people call me and they find the lab if it is necessary. I do have my equipment, as you have seen. So, you know, it depends on what the question is, which kind of material. For example, I'm working now with the University of Munich in Pompeii, in Naples, at the National Museum, Archaeological Museum of Naples. So I brought my equipment, and I also take samples to have atomic absorption and ICP analysis done in Munich. I will follow, of course, the process of analysis, because these labs are not used to work on ancient materials, so I have to be there. But yeah, it works very well. I have, of course, I've been teaching at university for many years, so I know the places where I can use the equipment. I work with the University of Trieste, of course, of Pavia, and so on.
More questions, please.
I understand you're inconvenient about the neutron analysis, but in which institute you did these experiments?
The PGA I did in Budapest.
Ah, I see. Thank you.
Please, more questions.
Thank you so much for a brilliant presentation. I'm wondering about these first examples of Niello on the Black Sea region.
Me too.
Yes. Do you have an idea where the producing center of these objects could
No, that's
be
the
localized?
question. That's the question. It is the question. Because these pieces I've been showing you, the Rhytons, as I said, they have been stolen. So it is difficult to say. But I asked, for example, of this, and he told me that probably the two pieces come from the northern coast of Turkey.
Mhm.
But of course you have wonderful pieces in Bulgaria, and I think all over the place. So we really should look for smaller objects. The problem is with Niello that sometimes it is completely covered by the patina. You don't see anything. They are completely hidden. It happens sometimes with gold inlays, for example, on bronze. The gold inlays are completely covered. You don't see anything. So, you know, they could be anywhere.
Thank you.
Please.
Thank you. My one question. Meet you mercury in applying methods of Niello.
Yes?
Yes.
Which
mercury.
method? X-ray diffraction. At first X-ray fluorescence.
Only silver Niello mercury for apply. Make mercury Niello and the surface and between the mercury. This kind. Yes. Yes or no?
No.
No. Thank you. Is the site of applied of the.
There is no mercury.
Thank you very much.
No. No, mercury is used for gold, for building.
Yes.
In
Yes.
some
It's very interesting.
not always,
Thank you.
but not for Niello.
No.
No.
No, sorry. No. It's not for Niello. This Niello, insert, for example, insert, Niello insert. And the surface of the object. We take the Niello, put on the object, and apply it
No, it depends.
by mercury. Yes. This question.
It depends on the composition of the Niello, how you insert it.
Yes. Good.
So if you have Niello with three different elements or lead, it is easy to cast. You can pour it. It is liquid. But if you have silver Niello, like on this writer here, you use it as a paste. So you can see it on the ice, for example, they are rough to keep the
Yes.
paste in place. No
No.
mercury.
So, if no more questions, I would just say that all, thank you very much. Again,